So this is the third installment or third step in my compost heater experiments, of course, reading and research and so forth. And I don't expect this to be, heating the house or anything at this scale. This is still preliminary prototyping, proof of concept, testing things kind of stage. So this is some dirt left over from the previous video about driveway project. I'm going to be making this pile roughly 5 feet in diameter, and I want to be able to walk around the perimeter of it. So that's this here. Now, inside that 5 foot, I'm going to have a 1 foot rim, outer rim circumference that's 1 foot in, and that's ground level. And then inside that, roughly 3 feet wide, is 1 foot down. So this 4 foot tall, just around 20-inch wide center part I'm reusing from the previous ones. In the background, you can see the totes, the 40-gallon-ish containers from the previous experiment, and I'll explain that coil here in a minute. So that is going to be recessed down, so 3 foot in the center, and then the outer part going out to the 5 foot is going to be there. Now, I'm going to take all the leftovers from the previous experiment, plus all here. I got 10 bags of shredded paper goods throughout the year, like junk mail, cereal boxes, pizza boxes, any of those paper goods. They're all shredded up and ready to go along with leaves. Even though it's like late October now, there's still a lot more leaves that come down, so there's more to go into it. So this is what it looks like with that put up. There's a 4 foot high tall aluminum screen, and remember in that center 3 foot that's recessed 1 foot. So there's that will be 5 feet high at the 4 foot permanent level. And then the you can see the probes, temperature probes, wireless, ambient. So these are the 4 sensors. It has an external long-range sensor. So there'll be 4 of them, 1 inch below the ground underneath of this, 1 foot up from the bottom, 2 feet up from the bottom, and 3 feet up from the bottom. They'll transmit into my data logging ambient system display inside the house. So this coil is going to be to help with aeration. If the pile is warm enough, there'll be a temperature gradient, a thermal siphon will develop, or a draft if you're thinking of a chimney for fireplace, and that thermal chimney effect will pull fresh air in to help aerate the pile. And this is then the inlet for that. I have a little piece of landscaping fabric cloth just tied off around the edge so like bugs and things don't go into it. So that's the purpose of that coil on the inside, is for aeration if the pile is warm enough to draw.
So you need airflow. That's one of the reasons you stir a compost pile. And then the commercial ones that have active aeration, where they're using fans and air pumps to either pump air in or pull it back out with a vacuum. Either way, it's airflow moving through. So microbes need air, water, nutrients, all that kind of stuff. But to avoid anaerobic conditions, you want aerobic. You want it with air. So you can get a perforated pipe at just about any home improvement place where you could get a pipe and perforate it yourself if you want to spend some time instead of money. This is a soaker hose. I'm going to try to show you it's perforated as well. So that is another option.
Now, separate from that, if that doesn't work, I do still have that bathroom fan pump, so I can use that to pull or push air through the pile through that perforated pipe if I need to. And this is a 2-inch wide, 2 foot long auger bit used for gardening to dig up a little hole for plants. I think that also might help to make it easier for me to do some stirring in the pile. Now remember that auger bit is not mixing the whole pile per se. It mixes a little bit right around the 2 inch or 2.5, 3 inches right around it, but it's breaking it up. It's helping to aerate by creating a little hole for that. So mainly that's just trying to get some aeration penetration, at least to the 2 feet or so depth of the auger bit. And they make bigger ones if you want more powerful. This is just a little 12-volt cordless drill I've had for a long time. So when the leaves had just started to fall, this is the end of October, I did get a little bit of leaves come down. So I have this leaf blower, and it converts from a leaf blower. You can switch it around so it's also a vacuum, and the vacuum has this tube that goes out. You can just put into a drum. I have a little trash can here with wheels on it. Makes it convenient to go around the yard and suck things up. But also in the process of sucking it up, goes through those impellers, which are creating the fan effect, which shreds them as well. So that's useful in that it's shredding it and things like that. But I ended up just kind of also trying the rake. The problem with the leaf blower vac, it does suck it up. It's less my muscle effort, and it does shred up the leaves, which will help with it. and things like that. But in the back of my head, part of the reason for this whole project is energy efficiency and trying to reuse these waste things like the junk mail, scrap paper, leaves that fall down, and so forth. Trying to reuse that energy into a more efficient way that helps me in some other way, so I can reduce, say, heating costs of water or space or something later. And spending a whole bunch of electricity in order to vacuum up and shred those leaves, although that might help the compost heater experiment, I don't know if that energy balance would be worthwhile. So, from an energy efficiency standpoint, I think I'm leaning more toward the rake. It's low tech, it's simple, it's inexpensive. It may not be as good for the compost pile because it's not shredding up the leaves as much. But from an energy efficiency standpoint, environmental standpoint, impact, and all that kind of stuff, the rake is a whole lot better. So I did try the leaves on the first drop of the first weekend that there were some drops, and I had about 2 of those trash cans worth that it sucked up with the vac. And then the second week I did the regular rake, which was about the same. So all in all, eventually I got more leaves to go in. It'll be falling over the course of November here. But altogether, it's going to be around, say, 500 or 600-ish gallons in this container for the season test. And it's going to take a while. I'll have to get back to you in the spring or summer or something when I collect and analyze all the data to see how well it does. I haven't added the fertilizer or starter to this that I did in the previous experiment, in some of the previous experiments, for 2 reasons. One, this is outside, so worms and stuff can come up through the ground. It's in contact with the dirt, it's in contact with the air, the aeration on the sides and through the center. There's a lot of contact with the environmental microbes, and there is some inoculation from the remaining balance of the previous experiments that are on the bottom of this, so that can inoculate and work its way up and through it as well. I do have some more, just part of the previous purchase I could use. I'm just choosing not to use it at this time. And just as a point of reference, to reminder, this is still prototyping, testing some of the things we've learned so far. From the books and things that I've read, I would have to go much bigger, maybe like 10 to 12 feet wide and 7 or 8 feet tall pile before it would be big enough to start generating things like thousands and thousands of BTUs for significant amounts of heating. So this is still prototyping small scale. To see how well it does. It's not going to be in the basement, so it's not going to have that sheltered environment where it was protected from, going much below 60 or whatever. So this is going to see the full winter weather, and we'll see how well it does.